Alright, so the next question covers a Taylor series. So how do you find a Taylor series of f of x equals cos x at x equals 0? So the Taylor series is another way to approximate a function at a value of a, x equals a, and it can be defined as this. So the Taylor series of f of x at x equals a is defined as f of x can be approximated by the infinite sum, or sigma from n to 0, of the terms of the derivative at a divided by n factorial times x minus a to the power of n. Okay, so that's how you find the Taylor series, and it's basically equates to a function at x equals a. All right. So they want us to find the Taylor series of f of x equals cos x at x equals 0. Okay, so we can alternatively write this as f of a. So when n equals 0, this is equals 0, and 0 factorial is 1, right? And so we just get f of a here plus f prime of a divided by x minus a, and then plus f double prime of a times x minus a squared divided by 2, plus so on, okay? So that's how you define the Taylor series, and we're going to find it for cos of x at x equals 0, okay? Alright, so we're going to basically, the rule of thumb with Taylor series is that you're trying to find the established pattern of the Taylor series, and by doing so, you can generalize it to find the infinite sum, or the general definition of the Taylor series of a specific function, okay? So let's just start calculating f of x and f prime of x, and when those derivatives are equal to our derivatives are at 0, okay? So we have f of x equals cos x, then f of 0 equals to 1. Okay, if f prime of x equals negative sine x, so I'm just going to keep writing these out. F double prime of x equals negative cos x. F triple prime of x equals sine x, and f to the power of f of the fourth derivative of x is just cos x. Okay, and if we keep going, f the fifth derivative is going to be negative sine x. Okay. All right. So what's the values of these? So f prime of 0 is 0. F double prime of 0 is negative 1. F triple prime of 0 is equal to 0. And f to the power of 4 of 0, or the fourth derivative of f at 0 is 1. And the fifth derivative of f of 0 is equal to 0. Okay, so if we kept going, we can realize or recognize that there's a pattern here, okay? So the coefficients are the derivatives is alternating series of 1, 0, negative 1, and 0. Okay, where the odd or the even values are the even derivatives have a value of 1, and the odd derivatives have a value of 0. Okay, so now that we've established this pattern, we can start to generalize our Taylor series here. Okay, so let's say that f of x, so this is the Taylor series of cosine, is 1 minus x squared. So we know that f prime of f of 0 is 0, so we're going to skip the first derivative and we're going to move to the second derivative. Okay, so So it's 1 minus, or so I guess we can write out the whole thing for now. 1 plus the first derivative at 0 divided by 1 and x minus 0 to the power of 1. And then we're going to write plus f double prime of 0 divided by 2 times x minus 0 squared plus f triple prime of 0 divided by 3 factorial divided by x minus, or times x minus 0 cubed. And then we have our last term here, which is, I'll just write it down here, is f to the fourth derivative at 0, 4 factorial times x minus 0 to the power of 4. Okay, so if we're to simplify this, f prime of 0 is 0. So this is 0 and this is 0. So all we're left with is, and this is negative 1 and this is going to be 1. So we have 1 minus x squared divided by 2 factorial plus x to the power of 4 factorial and so on. Okay. So next term is going to be minus, so and so on. Okay. So if we're to generalize this, we would have it to be the infinite sum. Remember to write the infinite sum all the time. So our signs are always alternating. So we can add a term that will always alternate our signs, which is negative 1 to the power of n. So when n is odd, it's going to be negative, and when n is even, it's going to be positive. Okay. And now we see here that our terms x squared and x4 and keeps going, it only includes even powers, right? So we can write here x to the power of 2n. So this ensures that our Taylor series will always just have even powers. And we see here at the bottom here that we only have even factorials. So we just write this 2n factorial, okay? And so these three terms helps to ensure us that our pattern remains the same, right? So this one makes sure that our signs are alternating. This makes sure that our exponents are always going to be even. And this makes sure that our factorials are always going to be even, regardless of the index number n, okay? So this is our Taylor series for cos of x at x equals 0. Alright? Cool. So this solution is correct. Alright, finally let's cover